Hey everyone, welcome back. Today we're going to look at infinite geometric series. If you've completed geometric series and sigma notation videos in the Pre-Calc 11 playlist, then today's lesson will be a lot easier for you. So we're going to look at infinite series first, and then we'll look at infinite geometric series. So let's consider this series here, Sn, where we're going from 1 to n of 1 over k squared. Right, so that's sigma notation, and if we expand it, 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, all the way to n, 1 over n squared. And this is a finite series. So what we're going to do is look at S1, that gives 1, S2 gives 1.25, S3, 1.361, and this keeps going more and more and more. It gets bigger and bigger and bigger, all the way to S8, let's say 1.5274. You can keep going to S20, and you can keep going up, more and more terms being added to the sum. And it turns out you can actually prove that as n goes to infinity, right, as we increase the number of terms in our sum, that sum will approach pi squared over 6. And that pi squared over 6 is approximately 1.645. Right, so if S20 is 1.5961, S100 might be 1.6, S1,000,000 might be 1.64, S1,000,000,000,000,000,000 might be 1.645. It gets closer and closer and closer to pi square over 6. And so this makes sense since we treat Sn as a sequence, right? We've got the first term, the second term, the third term, the fourth term, etc., 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 all the way to S infinity. So here's some different ways of saying the same thing. So as n goes to infinity, Sn goes to pi square over 6, where Sn is the sum from 1 to n of 1 over k squared. Right? So as n approaches infinity, Sn approaches pi squared over 6. If we take the limit as n goes to infinity of our finite sum, that limit is pi squared over 6. This is probably the most common way. The infinite sum gives pi squared over 6. This is another way. We're going to be using this notation here later. The infinite sum is pi squared over 6. We say Sn converges to pi squared over 6. The limit of n going to infinity of Sn is pi squared over 6. And so these are all different ways of saying the same thing. So let's look at a different series. Here we have from 1 to n of 2k. If we expand that, 2 plus 4 plus 6 all the way to 2n like that. And this series will not converge. So we say that the series is divergent, or we say the infinite sum diverges. Okay, so let's take a look at infinite geometric series now. Okay, so let Sn be a geometric series. We remember our formula for completing that sum. A is the first term, r is the common ratio, and r is not allowed to be 1. If r is between -1 and 1, then as n, the exponent, goes to infinity, r to the n goes to 0. Right? And just a couple examples here. If we have a half squared, 0.25, a half cube, 0.125, a half to the 4, 0.0625, and you notice that as we increase the exponent, the number gets smaller and smaller and smaller, right? So as n goes to infinity, Rn goes to 0. And so this Rn here becomes gone, and what's left is a times 1 over 1 minus r. And so our infinite sum is this equation. If r, the common ratio, is between -1 and 1, then that series will converge to this number, a over 1 minus r. So this is something you want to ask your teacher. Do you have to know this equation by heart, or is it going to be given to you? Okay, let's move on a bit. So when we say find the sum of an infinite series, we're asking for the value to which Sn converges as n goes to infinity. Right, so let's example 1, find the sum. 3 plus 3 over 2 plus 3 over 4 plus etc., etc. First term is 3. We notice that the common ratio is a half, right? Times a half like that. Half absolute value is less than 1, right? It's between -1 and 1, so that's good. So we're going to plug it in to find out what value this sum converges to. So that infinite sum is a over 1 minus r. A is 3, r is a half. So we have 3 divided by a half times the reciprocal like that. So 3 times 2 over 1, which gives 6. So the infinite sum is 6. All right, so just a reminder, as we add more and more terms, the sum approaches 6, right? That's what this infinite sum means. Okay, B. 5 minus 5 over 3 plus 5 over 9 minus etc., etc. So we notice that A is 5, R is negative 1/3, right? We're going times negative 1/3 times negative 1/3 like that. It is less than 1 in absolute value, so that's good. So we can use our formula to find what the sum converges to. So A is 5, R is negative 1 over 3, we plug that in. 5 divided by 4 over 3 times the reciprocal, 3 over 4 like that. And so the series converges to 15 over 4. Okay, C, 1 plus 4 over 3 plus 16 over 9 plus etc., etc. So A is 1, R is 4 over 3, and this is not less than 1. So this series diverges. Okay, D, here we have our infinite sum here. When k equals 1, we get our first term, and that gives 3, so that's our A value. Remember, our r is what's underneath the exponent here in a series. So r is 0.25 like that. It is less than 1 in absolute value, so that's good. So we can plug that into our equation, and that sum gives 4. So this infinite sum equals 4 like that. Okay, practice number 1. Find the sum A, B, C, and D. Go ahead and pause the video and answer that. Okay, we're back. A, first term is 5. Common ratio is 1 over 3 like that. 1 over 3 is less than 1, so we can use our formula. Plug in 5, plug in a third. 5 divided by 2/3, 5 times 3 over 2. 15 over 2 is the answer for our series, our infinite sum. Our infinite sum converges to 15 over 2. B, first term is a half. We notice that r is a quarter times 1 over 4 times 1 over 4 like that. It is less than 1, so that's good. So we plug in a half, r a quarter. A half divided by 3/4, so we get a half times 4 over 3, which gives 2/3 like that. C, first term occurs when k equals 1, and that gives us 2. The common ratio is not less than 1, so this series diverges. D, first term is when k equals 1, plug that in, we get 4. Common ratio is what's under here, so 2/3, and 2/3 is less than 1, so that's good. Plug in our formula. 1 minus 2/3 like that, which gives 1/3. 4 times 3 over 1, which gives 12. So this infinite sum gives 12 like that. And that's it. It's that easy. I'll see you guys in the next video.